Welcome to this video on interpolation, a simple technique behind smooth signals, realistic animations, and sharper images. We'll explore what interpolation is, how it works through real-life examples, and finish with a MATLAB demo showing signal reconstruction and image upscaling in action. Let's start with the first section. Interpolation is a technique that uses known data points to estimate missing values between them. It's widely used across fields, from upscaling images to filling missing frames in video editing and reconstructing signals in telecommunications. Let's look at an example. Imagine we've recorded temperature data throughout the day, taking measurements every 2 hours. A few days later, we ask a simple question. What was the temperature at 6:30? We check the plot, but there's no data for that exact time. The simplest way to handle this is to use the value from the nearest known time, in this case, 6 o'clock. This basic approach is called nearest neighbor interpolation. It estimates missing data by copying the closest known value. The result often looks like a staircase, as you can see on the screen. However, this method isn't very accurate. A more precise approach is to connect the data points with straight lines. This is called linear interpolation. While it's simple and provides much better results, the resulting graph can still appear segmented. That's why more advanced systems often use low-degree polynomials within each interval, carefully chosen to connect smoothly. This technique is known as spline interpolation. There are many other functions used for missing data prediction, such as the Sinc function, and even techniques based on the FFT. The choice depends on the application, as well as the behavior and complexity of each method. To wrap up, let's break down two concepts that are often confused: interpolation and extrapolation. Interpolation estimates missing values between known data points, as we saw earlier. Extrapolation, on the other hand, is used to predict values beyond the known range. For example, it can be used to predict future temperatures, stock prices, or population growth. And that wraps up the theory section. Now let's see interpolation in action using MATLAB. We'll explore two examples: one-dimensional signal interpolation and two-dimensional image upscaling. We start by clearing the workspace and closing any open figures. Then, we define our interpolation parameters, including the method and the upscale factor, which controls how many times we increase the resolution. Next, we create a 1D signal using the temperature example from earlier. We define the time vector with hourly observations and simulate temperature values using a sine wave, adding a bit of noise to make it more realistic. Now it's time for interpolation. We define a new time vector with 20 times more points and use MATLAB's interp1 function to interpolate the data. We pass in the original time and temperature samples, the new time points, and choose an interpolation method such as nearest, linear, or spline. You can find the full list of supported methods in the MATLAB documentation. Finally, we plot the interpolated temperature signal. To save some time, let's use a bit of video editing magic. Here's the code. Let's run it. As you can see, the original data has been interpolated using the linear method. Now let's switch to Spline and see the difference. As expected, the result is much smoother. In the second part, we'll look at 2D image upscaling. First, we load one of MATLAB's built-in images, then downsample it further to make the upscaling effect more visible. We generate the original pixel positions using mesh grid, followed by a denser grid for the new upscaled image. We then use the interp2 function, which works like interp1 but on 2D matrices, to perform the actual upscaling. Finally, we plot both the original and the upscaled image. As you can see, interpolation has made the right image much smoother, with more visible details compared to the downsampled version. And that's it for this video. If you want to keep learning, check out the next video in the DSP Fundamentals series. Thanks for watching.